For physics lover, I'll explain this two wire, which is current passed through each of them for 12th grade, chapter 5 in 12th grade. Look, first of all, I will remind you the right-hand rule for the straight wire. Right-hand rule say that when the current passes through a straight wire, our thumb represents the direction of current. Four fingers represent the direction of magnetic field around the wire. So if you wanted to determine the direction of magnetic field around wire 1, we have to do this. This is the direction of current. Four fingers represent the direction of magnetic field. So the direction field of magnetic field from right side, it will be into the page. What about out? What about left side? It will be out of the page, like this. Okay? This is the magnetic field of wire 1. What about wire 2? Wire 2, the direction of current like this, and the direction of magnetic field from left side, it will be into the page. From right side, it will be out of the page. Look, this is into the page. Then from right side, it will be out of the page. Look, from this portion, this is the magnetic field of wire 2 actually. From this portion, their magnetic fields have opposite direction. This is into the page, the another, it will be out of the page. What about this portion? Their magnetic fields have the same direction, into the page. What about this one? This one, it will be, their magnetic fields have opposite direction. If you have a multiple choice on this two wire, we have a multiple choice, which is an important multiple choice, which is related to your chapter review. Keep in your mind that you have to be careful that what is the magnitude of current which is passed through each wire. In which point it is possible that a resultant magnetic field of both wires are equal to 0. We have 3 points, K, P, M. In which points that the resultant magnetic field is equal to 0? When I1 equal to 1 over 3 I2. So when I1 equal to 1 over 3 I2, it means that when you did a cross production like this, you know that I2 equal to 3 times I1. So you know that I2 is greater than I1. When I2 is greater than I1, it means that the magnetic field of wire 2 is greater than I1. So we have a rule for the straight wire, say that B equal to mu naught over 2 pi ID. When the distance increase, magnetic field step by step decrease. So for the wire 1 and wire 2, you have to keep in your mind that this relation is so important. If you have a multiple choice, experiments show that B is inversely proportional with the distance from the wire. Okay, how you know that in which point that resultant magnetic field is equal to 0? Of course, at point P is not equal to 0 because they have the same direction into the page. So you will add both magnitudes is not equal to 0. So may you say that at point M or at point K, but which is the best answer? Suppose that you say that in point M. At point M, because the magnetic field of wire 2 is so great as comparison to wire 1, so at point M, magnetic field of wire 2 is greater than wire 1, so resultant magnetic field is not equal to 0. At point P, I told you. What about point K? Point K. The magnetic field of wire 2 is so great, strong, but when the distance increase, so it will be decreases. Okay, So at wire 1, because the magnitude of current passed through the wire 1 is so small, so also the magnetic field of it is so small, and the magnetic field of wire 2 also decreases. So both of magnetic fields at point K are equal but in opposite direction. So the resultant magnetic field at point K is equal to 0. This is the best answer. Okay, what about the another? Of course, it is not. Okay, it's wrong. So the best answer at point multiple choice A is true. At point what? At point K. I have another question, but I'll leave it for you and send to your friends so as to know the answer. I have another question, actually the same question, but it is different. Okay, like this, the same. So what is the difference between this question and another question which is at previous we did? Just this is the main difference between them. When we said that I1 equal to I2, in which point is that the resultant magnetic field is equal to 0, and send to your friends so as to know the answer. Please write the answer at the comment and I will help you and tell you the best answer.